And okay, perfect. So let me just share my screen. I'll show you everything that I have in mind for today. So I'll just start with a brief introduction. So my online name is Hydrogen. I'll be giving pure one with you guys tomorrow, but then um, I'm also doing further math along with that. So yeah, without any further ado, let's just get started. I sort of compiled a couple of things in a drive. So I'll just share that with you guys over here. So basically, it's kind of like some common silly mistakes that people tend to make. And then along with that, there's some questions that I'm planning to go through. And um, with that, I'll also sort of go through um, Feb March 2026. So you guys have kind of like three options. I could start with all the mistakes that students tend to make, or I could go through some questions um, that could sort of help you revise, or I could start by doing the Feb March paper. Okay, yeah, that's actually a good idea. Perfect. I'll just open that. You guys, I hope you guys can see the drive as well. By the way, I think I enabled sharing. Can someone just confirm if my screen is visible? Like, there's no lag, right? Okay, okay, good. So far, so good. Anyway, so I'll just start with this one over here, this strict identity. So you could be asked to sort of prove a specific trig identity. For example, in this case, you have sine square x minus cos x minus 1 or 1 plus cos x. So you would rearrange it and then you basically prove that it's equal to minus cos x, right? Pretty straightforward. Now, what I have seen is that most people tend to just ignore the question. They just look at 1 over 4 and they start by equating the identity above to 1 over 4. But that's not always the case. So in these type of questions, sometimes there could be some factor by which the identity is being multiplied, or even in the argument, it could be something like sine 2x, for example. I think I posted a drive link. I'll just send it again. Yeah, there you go. Anyway, moving on. So just keep in mind that it could be multiplied by some scalar factor, or there could be something like sine squared 2x. Like x could be multiplied by some variable factor as well. Apart from that, whenever you're solving your questions, please make sure that you're using the correct units. Like I've seen people mess up their degrees and radians, and that's like the easiest way to sort of lose marks. So I would say that just start by looking at whether they give you your domain in radians or degrees. Once you do the entire question, just double check to see whether the question is in radians or degrees. Moving on, for angles, just keep in mind that you always have to give it to one decimal place. Whenever your answer is in fractions, make sure that you write it in fractions. Don't make it messy by writing it in decimals. The same goes for statistics S1 as well. Otherwise, if there's some place where you have to write it in decimals, I would say that just write it to 3SF. Moving on. Um, so I'll, I think I'll go through some questions related to this. But anyway, I think there was the October November 25 paper in which wait, hold on, let me see if I can pull that up. I think it'll be better if I just show you guys the question. If you guys have any questions, I think it would be better if you just kind of ping me or you can DM me. Wait, hold on. Let me just open the question paper. It was October number 25, and then okay, okay, never mind. I'll come back to that later. But basically, the point being that whenever they give you some domain, so let's say that they tell you some constant k has to be between -1 and 2. And then, for example, you're given a question in which there's a quadratic for k. Okay, so you'd solve for values of k, and it could be possible that one of the k values don't they are like it's not valid in the given range. So you'd have to exclude that. Just make sure you kind of check that again when you're reviewing your question. After that, whenever you're taking the square root and it's like a it's the square root of a positive value, don't forget to take plus minus because you could lose some solutions by not doing that. Also, after that, whenever you're like done solving a question, I personally feel it's better to sort of double check your answer. So the best way is that if you have some question like integration, something related to integration, I think it's best to just use your calculator because your calculator has a feature to integrate functions, differentiate them usually. So if you have that option, good for you. You can use that to double check your answers. Another thing, please don't get confused between rules for integration and differentiation. Another thing is reverse chain rule. So, for example, um, yeah, I'll just write it over here. I'll go through this after I'm done with the silly mistakes. So, for example, if you have 2x minus 1 square, you're integrating this. So make sure you do 2x minus 1 raised to 2 plus 1, 3. So then you have to divide it by n plus 1, which is 3, divided by the derivative of the inner function. So that's basically reverse chain rule. So make sure you keep that in mind because these are like really silly mistakes. If you're going through this right now, you'd be like, what the heck? I don't care. I know how to do this. But the thing is, it's really easy to forget these sort of things when you're doing your exam because you're in a completely different environment. Apart from that, whenever they ask you to find the area under the curve or something, make sure you give the positive value because if the area is like below the x-axis, then you'll obviously get it in as negative. It's possible you could get it negative. So take the modulus of that. Uh, if you're multiplying all of your terms by some constant factor, so for example, if you're doing volume of revolution, right? So I'll just write that again. The formula for that is basically pi. You have some x1 pounds. If you're like uh, revolving it about the x-axis, that would be pi y squared dx, right? So in this case, what I usually do is I ignore the pi constant because they could ask you to give your final solution in terms of pi. So I just solve for this entire part first, but make sure that you multiply by pi like at the end. That's really important. You could easily lose a mark by that, especially if you're like aiming for full or something. It's really easy to lose marks. Um, Moving on, if you have extra time, so tomorrow is your paper. If you get any extra time, please don't sit idle. Don't look at other students solving the paper. Go through your work. If you have any solutions, you can, if you have enough time, you can input that into your given equation. Make sure that it's correct. Also, you like I said, use your calculator to double check. And then for trick questions, you can also use algebraic identities, right? So just keep in mind that you have, For example, a plus b the whole square. So that's a square plus b square plus 2ab. You have a minus b the whole square, which is a square plus b square minus 2ab. You also have a square minus b square. Okay, so that's just a plus b times a minus b. Um, so they're basically testing you for these sort of things. It's fine if you don't use these rules, but then it kind of saves you time as well. So I think that's pretty much it for common mistakes. If you guys want, you can go through this like tomorrow before your exam. So yeah, now after that, I could attempt the Feb March 26 paper, or I could start by solving sort of like topical questions, okay? But then they're sort of covering possible type of questions you could get. Okay, so I'll just start with the questions. Honestly, Feb March 26 was, from what I've heard at least, is really easy. So it's not really a good paper if you're practicing, but then you guys can still attempt it, I guess. Anyway, I'm gonna start with topical questions now. So, you're given function g and f. You can take your time to read. Um, so f of x is this, g of x is that, g of x is a quadratic. Now they have given you the function for f of x, right? So, yes. Now you have to state the domain for the inverse function. That would just be the range for this f of x function. Another thing, if you guys get time, I would say that just use Desmos and plot different graphs if you can, because it sort of gives you an idea about how things look like. Like for example, if you have 1 over x, right? So the vertical asymptote would be x is equal to 0, and the horizontal asymptote would also be y is equal to 0. You guys don't really need to know about that, but I would say if you guys learn a bit about rational functions overall, there's not a lot of time, but if you want to, you could sort of look at that as well. Anyway, right. So you have f of x, right? If you look at the function, you can sort of tell there's going to be a asymptote over here because the function is approaching that vertical line, and your second asymptote would be over here. So because it's talking about the range, obviously y cannot be equal to 1 in this case for f of x. That means the domain would just be x is not equal to 1. Then you have to find out the expression for the inverse function. So it's just x is equal to 2y. You just swap the x and y, right? So 2y plus 1 over 2y minus 1. Then just multiply. So 2xy minus x is equal to 2y plus 1. Bring the two y terms together. So you get 2xy minus 2y is equal to 1 plus x. Then you get y, 2x minus 2 is equal to 1 plus x. Y is equal to 1 plus x over 2x minus 2. Wait, hold on. I wanted to know, you know, do you know the shapes of graphs? So honestly, I think you should really know for questions related to functions, you definitely need to know the shape of graphs. So this is your x square. It's going to be a parabola. Then you have your x cube. Okay. Um, in this case, it's like a simple one, but then this is the general form of it. Uh, then you have your square root of x graph. You need to know about that as well. So you can think about it as a parabola that has been rotated. Then you need to know about 1 over x, right? So how a rational function looks like. Then you obviously need to know about your trig functions. So I'm just going through all these functions because if you get a question related to functions, the best way is to sort of sketch it if you can. Cos x is basically this, and then you have tan x, which would have we should have an asymptote at x is equal to 90 degrees, for example. In this case, it's pi by 2 because the scale is in radians. And you'd keep on adding pi. So for a tan graph, the graph repeats or oscillates every pi radians. And then for cos and sine, it oscillates every 2 pi radians. Okay, moving on. Now you have to find out g f inverse of 3. So you just use your calculator. You can input 3 directly into this. Uh, Honestly, I think these questions are a bit easy, so I'll just skip that. But this is your f inverse function. So you'd input x into this first to get a value, and then you'd input that into g of x. So I'm pretty sure the paper for Feb March is over here in the drive. You can just check the drive. The drive has the solution as well. If you guys wanted to check your working. Wait, hold on. Just give me a minute. Hold on. Okay, my laptop was tweaking. Can you guys still see my screen, by the way? Wait, can you guys hear me now? I just I muted myself. Okay, never mind. Wait, what was I talking about? Um, Before I okay, I'll just talk about why it cannot be found. Basically, it has to be one to one because it's a parabola. It doesn't have any sort of restriction over here, so you'd have to change the domain. Okay, for example, it would have to be x is greater than 0, or x has to be less than 0, so that a inverse function can exist. Okay, moving on. I think like this is a pretty common question at this point, but I'll just go through this as well, just so you guys know. This so that you guys can sort of revise. Anyway, you have a maximum point at 8 comma 12. You have a minimum point at 8 comma 0. The curve is a result of applying a combination of two transformations to a circle. The first transformation is some translation, and the second transformation is a stretch in the y-axis, right? So that tells you that there is no sort of transformation in your x-axis. So if you look at the x-axis, there wouldn't be. It's basically similar to the original circle. Also, another point is that each side or like each unit over here is 2 units, right? So, okay, let's just get started. State the scale factor of the stretch. So initially, if you can use the radius as you can use it to sort of compare the stretches, right? So in this case, your radius is the same as the original radius. It's 1 unit long. But if you look at the y direction, the radius is actually 3 units long, right? So that tells you that you stretched it along the y-axis by 3 units. So it would just be 3. State the radius of the original function circle. Okay, so it's it's basically wait, let me just draw it so that guys get an idea. Because you kind of stretch it by 3 units, when you sort of decompress it, or if you undo the stretch, you're basically doing 12/3, right? So your maximum would be over here if you unstretch it, kind of like this, right? Now you can look at this. So your radius is from 8 to 10, for example. So that's just 2 units. And then say the coordinates of the center of the circle after the translation has been completed, but before the stretch is applied. So um, if you look at the final circle, it's 12 units long, right? So the center would be right over here. Now, after you unstretch it, it will be at 8 comma 2. So that's basically your answer. Now state the coordinates of the center of the original circle. Now you already know what the center is after you apply the translation. So if you undo the translation, then you would basically get your original circle, circle center, right? So in this case, you added 7 and you subtracted 3. So you just do the opposite, subtract 7 and add 3. That gives you 1 comma 5. So so far so good. I hope no one has any sort of doubts. Okay, moving on. So now we have this question over here. The diagram shows a circle with equation x squared plus y squared minus 6x plus 4y minus 27 is equal to this 0, and then you're given the point 5 comma 4. So then you're told that the tangent to the circle at P meets the x-axis at A and the y-axis at P, and they are asking you to find the area of triangle OAB. So basically, what you can do is find the tangent at P, then you can find out the x and y intercepts of that, and you can use the area of a triangle formula. So again, this is pretty straightforward, so I don't think I should waste time on this. Basically, just use the logic that you have your center over here. Now, your center would just be so the thing is, when you have your equation in this form, you can basically divide the coefficient of x and the coefficient of y by -2 so that you can get your center. So it would just be -6 over -2, comma, uh, 4 over -2. That's basically your center, C3, comma, -2. So once you get your center, you know that if you look at the radius, if you find out the gradient of from the center to point P, that would be perpendicular to the tangent formed at P. So you can just use the rule that m1 into m2 is equal to -1. You can find out the gradient of the tangent and then just find out the x and y intercepts. Again, pretty easy. Now, points Q and R also lie in the circle such that PQR is an equilateral triangle. And then you have to find out the area of that. So first of all, what's P, Q, and then R? So this is your center is still 3 comma minus 2. Um, P, Q, and then R. It's kind of better to sketch if possible because that can really help you out. So let's see. This is your radius from C to P, C to R, and then C to Q. So since it's equilateral, basically all the three sides are equal. And another thing to keep in mind is that, for example, if you look at CQ, right? CQ is just R, and then CP is also R. So you kind of get this sort of triangle formed by CQP, for example, right? So this is just isosceles. So that means this would be 60 degrees, this would be 60 as well, right? And then, wait, hold on. Uh, yeah, okay. I thought I was messing up. Anyway, this is 60 degrees. This would be 60 degrees, 120. So this would be 60 degrees as well. Wait, no, what the hell? Dude, I am freaking out right now. I think. Um, wait, hold on. Okay, no, I think I used a wrong idea. This would be 60 degrees, then this would be 60 as well, and then this would be 60 as well, right? Because it's equilateral. Now, after that, um, you can think of it as bisecting, right? So this over here would just be 30 degrees. The other one would also be 30. So because of that, um, this angle over here would be 120 degrees. Okay. Yeah, I kind of got confused for a second. I'm sorry. Uh, okay. So you know that the angle over here is 120. It's 30. This is 30 as well. Uh, so let me just draw a small sketch. 120 R and then R. So for 3 comma minus 2, I just there's this rule that you can divide the coefficient of x by minus 2 and the coefficient of y by minus 2 to get the center. There's also another rule that the radius is equal to g square plus f square minus c under the root, right? So you can actually use that to find out the radius because that's important in this case. So 9 plus 4 plus 27. Okay, so that's just equal to 2 root 10. Uh, I'm pretty sure you're supposed to know these formulas. You need to know that the radius is the square root of g square plus f square minus c, and then the center is minus g comma minus f. Just I would say if you guys don't know about this already, it's best if you learn about them or memorize them because it can save you a lot of time. Anyway, moving on. So this is like 1/3 of your equilateral triangle, right? The radius is 2 root 10, 2 root 10, and this angle over here is 120 degrees. Um, so you could do that, but then that requires implicit differentiation. You don't have that in pure one, so it's not really necessary. But then, if you want to do implicit differentiation for a question like this, go ahead. I guess uh, the area would be equal to half AB sine C. So AB, um, if you look at this triangle, AB is just the R, right? So R square, so 2 root 10 square times sine C, which is sine 120. This is getting really messy. I'll just write the final answer um, below. 2 root 10 square. Okay, so I got the area of one of the triangles as 10 root 3. Alright. Uh, now, the areas of all these three triangles would be equal. So you can just simply multiply it by 3 so that you basically get your area. So that's just equal to 30 root 3. Let me just check if my working is correct. Okay, yeah, that's correct. Anyway, moving on, some more function related questions. So you're given f of x, which is a rational function, g of x, which is a linear function, and then you're told that the domain is x is greater than equal to a, less than equal to b for g of x. Um, wait, which 2 root 2. So the radius is just g square plus f square minus c, where c is equal to this constant right over here. So I just use the formula right away. G, you can think of G as 3 and then F as 2. Um, so, wait, oh wait, I have a question. Like finding areas questions, do we round it up to 3 sig figs, like what the front cover says? My answer is 4320. Do I round it to 4300? Yeah, 4320 is 3 SF, so that's acceptable. If your question doesn't specify anything, if they don't say that give your answer to these many decimal places or these many sig figs, simply just give it in 3SF. Okay, moving on. Find the greatest value of A and the least value of B, which will permit the formation of the composite function gf gf of x. G of x is basically a linear equation, right? So no matter what the value for x is, it's just going to accept any sort of value. Uh, I think there is AWRT like in the MS, but it depends. Just don't risk it, I would say. Um, okay, so GF of x. So you have your linear equation and you're inputting 48 over x minus 1 in that to get some function. Now, I don't have to really find out what the new function is. Um, so, in your rational functions, they usually tend to be tricky. But if you want to make a rough sketch, x is equal to 1 would be your vertical asymptote. So, it's something kind of like this. Okay. It's not drawn to scale. Wait, no. Sorry. Something like this, okay? And they're telling you that x is greater than equal to 3, less than equal to 7. So this part right over here, let me just mark it with this. So it's kind of like one-to-one. You can think of it as a one-to-one function. So its minima and maxima is pretty simple. Like you don't have to overthink about what that would be. Because look, they have already given you a domain for your f of x, right? So essentially, since you're finding out the acceptable values for a and b, and the thing is, when you're doing, hold on, when you're doing g of g f of x, right? So if you look at this, your domain is going to be the range of your domain for the composite function, or your domain for g of x would be the range of f of x, because you're inputting f of x into g of x, right? So you can just find out what the range for f of x is. You do that by inputting 3 and 7. I'm sort of trying to explain how it works as well, because I could just do the working right away, but I feel it would be better if I explained it. Anyway, you just do f of 3 and then f of 7, okay, to get your maxima and minima. So if you do that, it's 48 over 3 minus 1, so that's 24. And then you have 48 over 7 minus 1. 1. Okay, so that's 8. So obviously your maxima would be 24. Like if you look at the graph for f of x over here, um, your maxima would be, wait, no, that's wrong. Anyway, your maxima would be 24, your minima would be 8 in this case. Now, those are the values you're going to input into g of x, right? So if I just make this, you're inputting 24 and 8 into g of x. There can't be any value greater than 24, or there can't be any value smaller than 8, because you already have a domain for f of x. That's why the largest value possible in the domain of g of x would be 24. So we just look at this. X is greater than equal to 8 and less than equal to 24. So A would be equal to 8 and then B is equal to 24. Okay, moving on. It is now given that the conditions for the formation of your composite function is satisfied. Now find an expression for fg of x. Let me see if there's some square root thing. Only thing. Yeah, there is no square root thing involved for finding this. So I'll skip this. It's pretty straightforward again. Now find the um, inverse for that. So again, that's pretty easy as well. So I'm not going to waste your time on that. The reason I included these these questions is because you can just practice them like right before your exam begins, so that you sort of revise everything that there is involved. Now we come to differentiation. So most of these questions would be related to um, rates and everything. So, okay, yeah, this is the first question. There is not a lot of space though. Sad. Anyway, so um, you're given a water tank where the depth of the water is in x meters. So, depth is basically x. So, domain of range of, wait, hold on, let me go back. So, the domain of range of, wait, uh, let me just explain it to you again. The range of f of x would be the domain for g of x. If you're forming the composite function g or f of x. Because look, in um, g f of x, you can think of it as you have your function g of x, right? But then your x would be f of x in this case. You're basically inputting f of x into g of x. So whatever your output values are, or whatever your f of x values are, that would sort of be the domain for g of x. It makes sense if you think about it in a structure, I guess, in an order. Anyway, moving on. The volume of water in the tank is given by this. Um, and then water is being pumped into the tank at a constant rate of 36 meter cube per hour. So that's one of the rates. You should identify that uh, right away. So you can look at the units to understand what variables they're talking about. Over here it's meter cube and it's per hour. So it's dV by dt. So dV by dt would be equal to 3.6 over here. Now, find the rate of increase of the depth. So depth is basically x. So we need to find out dx by dt uh, when the depth is 4 meters. So they also told you when x is equal to 4. Um, I'm pretty sure you do get questions like these. Hi, Optimus. Anyway, so you can use chain rule for these sort of questions, okay? So you have to find out dx by dt. Let me just write that. This isn't a paper. I basically compiled some difficult questions on a drive, and I'm solving them. I hope we can like maybe post the drive somewhere. I'll try posting it. I'm recording the session as well, so I'll post it recording to the drive as well. Um, anyway, hold on. Okay, I think I'll answer this out. Um, how do we know in which order we have to write transformations? That part is confusing me. What's the rule? Also, the type of questions where they ask you to determine whether a function is increasing, decreasing, or neither. Uh, so I have questions related to transformations in here. I also have a question related to whether the function is decreasing or increasing. So I will come to that. Just wait for a bit. I'll explain the concepts behind that as well, so don't worry. Um, is there anything else? Okay, just wait for a while. I'll come to that. Anyway, dx by dt would be equal to dv by dt times dx by dt. Sorry, dx by dv. This is basically chain rule where you sort of try canceling out the rates. So the you can treat these as variables. It's notation. It's not actually you're not actually canceling out things, but you use these notations to sort of work with rates. So I wrote dx by dv because then I know that I can basically cancel out dv, right? So I just have to find out dv by dx because I have the formula for that already. I have to input x into that so that I get dv by dx at x is equal to 4, and then I can take the reciprocal of that. So I'll just do that about dv by dx is, so 243 is just a constant that does not matter. Then multiplied by 3, okay? And then another thing is that you have minus x in this case, okay? So I'll just write the general form. If you have a composite function like fg of x, right, and you're taking the derivative of that, if you're differentiating it basically, the derivative would be equal to f g f prime g of x that times the derivative of the inner function. So I'm just sort of going through the concepts as well. Anyway, you multiply 3 with 1 minus 1 over 3, and then your inner derivative would be, inner function's derivative would be minus 1. So you end up getting 9, uh, sorry, 9 minus x square. Okay, this is dv by dx. And then you would input x is equal to 4 to get dv by dx at um, that point. So that's just 9 minus 4. So 5 square, which is 25. Okay. So, yes. Okay. Now, after that, you know that dv by dx is 25. So dx by dv would be the reciprocal of that. So you can say that dx by dt would be equal to dv by dt, which is 3.6 into the reciprocal of that, which is 1 over 25. Now, if you multiply that, that would give you 18 over 125. Now, another thing is that for these type of questions, the units are really important. Uh, in this combination, always the same. Wait, what do you mean? I did not get you. Um, no, that's the thing. It's not equal to minus 1 over 25 because remember that your inner function is 9 minus x. The derivative of that would be minus 1, right? So, like I said, this is your rule for differentiating composite functions. So, make sure you multiply it by the derivative of the inner function as well. Just keep that in mind. Anyway, now here's the thing. I mean, like the rate of change. Uh, just send me the question. I'll answer that in a bit. Let me just finish this right now. Okay. So if you just make sure that you focus on the units as well when you are going through questions like these because units matter a lot. Now, as you can see, dv by dt in this case is meter cube per hour, right? And you're using that rate to find out dx by dt. So your new dx by dt would be in the units meter cube per hour. Okay. Now the question mentioned that you have to give your answer in centimeters per minute. So there would be an additional mark for converting your final rate into a centimeter. Sorry, it's not meter cube. I'm so sorry. It's dx by dt, right? So meter per hour. So you have to convert that into centimeter per minute. So you just multiply that by 100 over 60, right? Because it's pretty obvious. I don't have to explain it. So 18 over 125, which is in meters per hour, you would multiply that by 60, no, 100 over 60, so that you can get your final answer in whatever that is. I'm not going to calculate that. That's too takes a lot of time. Anyway, it doesn't. But okay, centimeters per minute. Yeah, there you go. For example, in dx by dt is equal to dy by dt times dx by dy. Um, Here's the thing that won't really work. You're not really canceling out anything. Okay. Um. Yeah, that wouldn't work. You would have to form some new um date notation. Uh, that really depends. I have the recording anyways. I'll be recording this anyway. So if you guys want to leave in between or anything, don't worry. I'll be sharing the recording. Okay. So somebody was asking about decreasing and increasing functions. So I'll explain the concepts. Wait. If we differentiate 243 minus 1 over 3, 9 minus x the whole cube, we get dv by dx as this, right? You get 9 minus x squared. That's correct. To which dx by dv, wait, so dx by dv is negative reciprocal. Uh, why are you taking the negative reciprocal for this? If you have some rate like dy by dx, okay, that would be the same as 1 over dx by oh my god, dx by dy. You don't take the negative reciprocal. You just you know what, just treat these as variables. Okay, think about y over x. Okay, let's say you know x over y, so you simply do 1 over x over y to get the fraction y over x. Don't think about it in some other way. Just treat them as variables. That's going to make your life easier. Anyway, I'll just briefly go through functions, its derivatives. I think it's best if I go through first derivative and then second derivative as well, because they could ask you to check whether it's a maxima or minima. Most people tend to memorize that if it's greater than 0, then it's going to be a minima. If the second derivative is less than 0, it's going to be a maxima. I don't really want to do that, so I'll just yap a bit about it. Anyway, let's say you have a function f of x, okay? Um, you know what? Let's sort of have some fun. So I open this in Desmos because Desmos is really helpful in these sort of things. Okay, so I'll just sort of try analyzing a function. What should I come up with? I don't think. I think I'll just go with a quadratic. Okay, so 5x squared. That's pretty easy to understand. That won't take a lot of time either. So 5x squared plus 6x plus 7. 6, 7. Anyway. So this is your quadratic, okay? This is your curve. Your question would specify it as the curve or something. Sometimes they specify the curve as dy by dx as well. So keep that in mind. Make sure you know what the curve or the main focus is. Okay, this is a function. I don't like this. It needs to go a bit down. I'll do -7. Okay, much better. This is going to be your f of x. Hold on, let me see if you can. Yeah, you can find out the derivative now. Your derivative would be a linear function, right? Because the thing is, when your f of x is, wait, I'll just write that over here. When f of x is, for example, cubic, okay? And this is important because you might have to do sign diagrams and stuff as well when you're working with questions like these. So let's say f of x is cubic. So f prime of x would be quadratic. Okay. F prime prime of x would be a linear. Now, in this case, your f of x, wait, let me just erase that. I did not erase that. Okay. This is painful. Anyway, yes, back to your function. So in this case, f of x is your quadratic, right? So your f prime of x would be a linear. Now you can sort of analyze to see what happens at each and every point. Uh, if you'll see, your gradient is equal to 0 at -6 comma 0, right? This is your f prime of x. And then if you go right below that, your turning point is at minus 0.6 comma um, minus 8.8. So whenever you have a curve that's turning, okay, just to sort of give you guys that sort of a sense. Now, in this case, it's a maxima, right? You have a maximum point. So the gradient would be like this if you're looking at, for example, the point over here. Now, in this case, the gradient is obviously positive, right? Now, if you look at the gradient at the turning point, okay, that's not that turning point, right? If you look at this, in that case, your gradient would be 0, and then your gradient would be negative after you move ahead. Like, so, for example, at a point like this. Now, your your second derivative, which is, let's say this curve over here is equal to y. So d2y by dx2 is, in simple words, the rate of change of the function. Now, rate of change of the function is basically your gradient. So basically, your second derivative just tells you what the rate of change of your gradient is. So you don't have to visualize that, okay? It's meant to be U-shaped because yeah, I'm not plotting this graph over here. I'm just giving an example about how if you have a maxima, and then I'm going to talk about the minima as well. So in this case, when you have a maxima, your gradient is going from positive to 0 to negative, right? So your overall change is that your Basically, if you look at dy by dx, right, it's going from positive to 0 to negative. Okay. Yes, I will be uploading the recording. Um, so don't worry. Anyway, your gradient is going like this. So you can say that your rate of change of the gradient is negative. Your gradient is basically decreasing as you go up the mark. If you go towards the maxima, and like if you go ahead of the maxima, like ahead of the x coordinate of the maxima, it would start decreasing. So in this case, your second derivative would be negative. Okay, it's decreasing. So if you want, you can try sort of using your hand to make a downward U. That's how I use it. I did share the drive link a while back. If someone could share that, that would be great because um, people keep on joining, right? So yeah, thank you. This is for a maxima, and then for a minima, it would be the complete opposite. I'll just do it quickly. It's going to be negative. Your gradient would be negative for this minima at this point over here. Then over here, it would be 0. Over here, it would be positive. So your rate of change of the gradient is that your gradient is basically going from negative to positive, right? So you say that your gradient is increasing. So your rate of change of the gradient is positive. That's how, that's the entire thing about second derivatives. Now I'll talk a bit about f prime of x as well. Can it be neither positive? Wait, are you talking about the second derivative? Are you talking about inflection points? Uh, we don't have inflection points. Um, yeah, so I'll give you an example. The best example for that is x cube. Okay, if you look at x cube, uh, so let's say you have a point and you're slowly increasing. Okay, so your gradient over here would be positive. Obviously, it's going to be positive. You go over here, your gradient is 0, but then it's again increasing, right? It never decreases. Like your gradient is never negative or anything. It's positive over here, it's positive over here. So you this would be a sort of an inflection point. It's interesting, but I'd say just check it out later because it's not in your syllabus. So your second derivative would be 0 at this point, and you'd have to check whether there's a change in signs. Anyway, now I'll just talk a bit about increasing and decreasing functions. So we'll just use the same example, okay, because this is a bit simpler. So now let's say I take a point over here, or you know what, x square is easier. Never mind. Wait, my laptop is tweaking a bit. Okay, I'm back. All right. So this is x square, right? Uh, if you take some random point like to the left, coordinate geometry. Just tell me what you want to cover. I'll um, I'll see if I have some question related to that. Then I'll focus on that. I don't really mind though. Anyway, if you look at a point like this, the gradient over here is negative, right? If you like draw the tangent to the curve over here, it's negative. Then you go. So at the same time, observe. Yeah, exactly. Observe your f prime of x, right? Because your f prime of x represents your um, gradient function. So when the gradient is negative, as you can see, the y coordinate of f prime of x or f prime of x itself is negative when the gradient is negative, which makes sense. The gradient function has to be negative when the gradient at the curve is negative, right? Now, as you go closer towards x is equal to 0, the gradient is, um, if you want to say this qualitatively, your gradient is basically approaching zero, right? Um, so if you look at your f prime of x, it's slowly increasing. Like it's approaching zero in this case. Uh, now, till the point where you have your minima, right? Now, if you go ahead of this, your gradient is positive. So that's why the gradient would be positive as well. So my point of doing this was that now I can talk a bit about this question over here. So you're told, okay, my laptop. Okay, no, it did not. Your an increasing function f is defined for x is greater than n. It is given that the um, gradient function is this quadratic. Find the least possible value of n. So for these type of functions, you can start by finding the vertex, or you can write it in the root form. Either way works. Um, no, you will not derive it, like you will not differentiate it, because this over here is your gradient function. So let me just explain what I'm doing. Let me just find out the roots first. Okay. Um, okay. So you can rewrite this as x minus 4, and then um, x minus 2 is your f prime of x. Okay. So don't worry about what the f of x is. Just look at f prime of x. Just make a rough sketch of this first of all. Okay. So your intercepts, x intercepts or your roots are 2 comma 0 and then 4 comma 0, right? So your f prime of x would be something like this. You can verify that by looking at this over here if you want, although you won't really have this most. So this is your f prime of x, right? Now they're telling you that your f of x, your curve f of x, is an increasing function. So and there's some domain given, which means for all values of x, your function has to be increasing. Now, you have to relate this back to what I was talking about. So basically, when f prime of x is equal to 0, that's when you have some sort of a turning point. Okay? Okay, right. Yeah, thank you. Wait. Anyway, when f prime of x is okay, that's reading me by the way. When f prime of x is less than 0, it's negative, right? Your gradient is negative, which means that your function is decreasing. So this is a general rule that you need to know about, because this is going to be really important. And then when f prime of x is greater than 0, so it would be something like this, right? So it's basically increasing. And rather than trying to memorize how this works, just try visualizing a graph, for example, and make a tangent at that point. That'll give you the best idea about um, how these concepts work. Increasing. Did I spell that right? I don't remember. I don't care. Anyway, right. So they're telling you it's an increasing function, which means that for all values of x, your derivative function or your gradient function has to be positive, because your function only increases when your gradient function is positive. So this was 2 over here, right? And this was 4. So x would have to be greater than 4 so that the gradient is positive in all cases. Yeah. So your gradient function basically tells you the nature about your f of x, and you can sort of use this. This was a 5 marker for some reason, by the way, which is crazy. Um, no, it was not. My bad. It's 3 marker. Oops. Anyway, moving on. Now you have another question. So you have an open tank. It's a prism. Okay. Just take a moment to read this. There's an identical isosceles triangle. Okay, buddy. Um, just take a moment. I'll just read the question as well. So they're telling you that angle ABE is equal to angle BAE, which is 30 degrees. So that means this is an isosceles triangle, okay? So obviously, if you just without understanding the question, you know that this is 180 minus 60, so that's 120 degrees over here. Yes, you do have this in your syllabus because this is a rate related question. So okay, moving on. The length of AD is 40 centimeters. Okay, so if you guys and just recall, whenever you have some sort of a volume which looks like this, right? So you can think about it as the cross-sectional area at any point, like for this solid, is basically the cross-sectional area is the same. So the volume for these type of solids is basically cross-sectional area. Okay, why is that equal to cross-sectional area times the length? Okay, that's what you do for these type of questions because it's a prism in this case. So after that, they're telling you water is poured into the tank at a constant rate of 200 centimeter cube per second. Okay, so you don't need to understand what that is. It's best if you understand it, but just it's basically dV by ds because the units in this case is centimeter cube per second, right? So dV by ds would be equal to 200. Okay, moving on. The depth of water t seconds after filling starts is h centimeter. So this is your original prism, right? It's completely empty, and basically you're pouring water into this. So it would start by accumulating below, and then it would start rising. So you get the idea, right? Then after a point, it would be completely black. So okay, now show that when the depth of water in the tank is h centimeters, the volume of water in the tank is 4 root 3 h square. Okay, so first of all, like I said, the volume is just cross sectional area times the length. In this case, you know that the length of um, this volume is basically 40 centimeters. So you don't really have to focus on the length. You have to focus on the cross sectional area, which they have already sort of given you as a diagram. So you can annotate this, okay? There is no specific equation for rates of changes. I can give you an example if you want. The the entire concept is that it's some sort of a notation where you treat the variables, where you treat those rates as variables, okay? So if you have dy by dx, for example, that would be the same as dy by dt times dx by dt. And then let's say you know what dx by dt is, but you want to find out dx. Sorry, let's say you know what uh, okay, I wrote the equation wrong. My bad. You're multiplying it by dt by dx. Okay. So you just take the reciprocal of dx by dt to get dt by dx. Anyway, moving on, we really need to sort of speed up. So when the depth of water in the tank, so h is basically your depth, okay? It's the same thing for volume. Your h is this vertical line, and it's going to increase with time. Now, like we already found out, the third angle in this triangle would be 60 degrees. So if you just separate them into two equal triangles, this over here would be 60 degrees. Okay. Now, here's the thing. Now, let's say at any given point, okay, so let's assume that for some unknown h value, okay, the volume has filled by some amount, and the shaded region, okay, so the shaded region over here represents the cross-sectional area of that volume. So let's say you somehow found out what the cross-sectional area is. Then you just multiply that by 40 centimeters to get the volume. Now, how would you even find out the cross-sectional area over here? H is basically your height in this case, and it's just a isosceles triangle. So you just have to find out, you already have the height. You have to find out this side over here so that you can do half into base into height, right? Um, so wait, let me make a better diagram. Um, okay, this is H. You need to find out opposite over here. This is your hypotenuse. So you can use the formula that tan 60 would be equal to the opposite side over adjacent, which is H in this case. So opposite would just be H tan 60. Now, it's also in terms of H, so that just makes life way simpler. You can get questions like these. I think this is somewhat a uh, old question, but then it can come up. Yeah, there's definitely a chance. Um, so anyway, this is your height. Okay, so the area of this thing over here would be half into base into, sorry, half into height into opposite, right? So you'd have to multiply that by 2 so that you get the area on the left side as well. Because you can think about it as this is just opposite over 2, okay? So you'd multiply it by 2. So area would be equal to half into uh, 2h tan 60, half into opposite into height. Okay, this cancels out. You get h squared tan 60, and I'm pretty sure tan 60 is some value you can represent. Wait, hold on. So tan 60 would be root 3. Okay, and you can see that it's kind of similar to your part I. So volume would just be 4, wait, hold on. Yeah, 40 times this. So volume is equal to h square root 3 times 40. This is pretty easy if I'm being honest. Because in questions where they give you a lot of data or a lot of content, it's one of the most easiest questions. Anyway, the next part says find the rate at which h is increasing. Okay, so you have to find out dh by dt. So this is dh by dt. Okay, you have the formula for volume and like the formula for volume which is in terms of h. So you could find out dv by dh, which we can find out by differentiating the formula for volume. And what else do we have? So they have also told you that the dv, the rate dv by dt is 200, right? So you can write the equation. You already know what dv by dt is, so just write that. Um, right, and you can find out dv by dh, right, by differentiating the formula for um, your volume. So this would just be multiplied by dh by dv. Now, dv by dt, like I said, is just 200. The question already told us that. Hold up. That times dh by dv. I'll just write the. I don't really have space. Hold on. This isn't a specific paper. These are some compiled questions that I'm doing, so that we kind of go through some difficult questions, so that even if there is some possibility of questions coming that are like really difficult, you guys can at least attempt them. You know. Okay. So v is 40 root 3 h square, right? This is v. So dv by dh would be 80 uh, root 3 h. Okay. Um, and they told you that you have to find out when h is equal to 5. So you just do 5 times 80 root 3. 5 times 80, that's just 400. So 400 Okay, my laptop is fighting with me again. Anyway, 40 root 3. So this is dv by dh. So you take the reciprocal of that, and that would be 1 over 400 root 3, which is equal to 1 over 2 root 3. And look at the units. Make sure you include the units for relate, rates type of questions. Okay. So height is in, it's in centimeters. Time is also in seconds. So height centimeters per second. That's pretty much it for this question. Um, do you guys want to do more questions related to this, or should I move on to trig and then sequences? Um, okay, we can do this. I have no issue. Oh, it's so. Um, should I just talk about how you would approach this question? Because if you do get questions, I already did some questions related to differentiation, to be honest. But then I talked about it as well, so you can check my recording. Break. I, you know what? Actually, let me take a break. I've been speaking since a while, so I'll take a break for 5 minutes. That's that's good enough, right? No, we are not unmuting you. Um. Okay, yeah. Just come back in 5 minutes or something. We'll just take a break then. Okay, I think that's good enough. Um, let me just share my screen. Hold on, give me like a minute. Um, wait, can you guys see my screen right now? Okay. Um, all right. What do you think the threshold is gonna be? I think if it's really easy, like Fermat, then it's a bit concerning because yeah, it might be high then. Mhm. Anyway, moving on. Just I'll just go through the question once. Um, all right. So the inside lane of a school running track consists of two straight sections. Okay, each of length x meters. So this section over here is x meters. This section over here is also x meters. Okay. Now then there are two semicircular sections, each of radius r. So this would be r as well. So this sort of tells you, gives you an idea that it has the same radius. So it's basic. You can kind of think about it as like an entire circle, right? Um, moving on. The straight sections are perpendicular to the diameter of um, the semicircular sections. Okay, so they have made these boxes, cool looking boxes. The perimeter of the inside lane is 400 meters. Show that the area, which is in meter square, uh, of the region enclosed by the inside lane is given by A is equal to 400 r minus pi r square. So, um, how do you find out the area? Well, you can think about this thing over here as just being a rectangle, right? At least for the straight part, where the height would be 2r and the length, the width would be x meters. So it's the area of the rectangle plus the area of one complete circle. Like I said, you can think about this as two semicircles that you're adding up. So area would just be equal to pi r square, right? And that plus 2r times x. So plus 2xr. Okay, but that's not the end of it. Because in your final form, it's completely in terms of r. Okay, so you have to find a relation between x and r. So okay, what has your what has the question given to you, like some value or something? Uh, so there's obviously there's perimeter over here. So you could make a equation for perimeter which has x and r. Then you can rewrite it in terms of r, and then just substitute x with r. So perimeter, which is 400 meters long, would be equal to, so 2 pi r, because again think about it, it's 2xr because this thing, like half of this is, wait, let me just erase this. That did not erase it, bro. My laptop is fighting with me again. Hold on. Anyway, this thing over here, the half of that is r, and then the entire length would be r times 2, right? Um, this is r, so this entire thing would be 2r. Okay, I hope that's clear. Yes, moving on. Your perimeter would be, so like I said, it's two semicircles which have the same radius. So treat it as a complete circle. The circumference would be 2 pi r. That's pretty straightforward. 2 pi r. And then what are you missing out on the perimeter? So x, right? X from above and below. So 2x. Again, pretty simple. Now you just divide by 2 if you want to make it simpler. So pi r plus x, take pi r to the other side. So x is 200 minus pi r. Now take that thing, um, shove it over here, and then you get pi r square plus 2r, and then 200 minus pi r. That gives you your final answer. I'm not going to simplify this, but that basically gives you this thing. A lot of straight lines. Anyway. Okay. Um, Let me just erase these things. Now, in part 2, given that x and r can vary, uh, show that when A has a stationary point, there are no straight sections in the track. Okay. So determine whether the stationary point value is a maxima or a minimum. So first of all, they're telling you when A has a stationary point, uh, uh, when A has a stationary value, okay, there are no straight sections in the track. And then uh, if you look at the track uh, in its current state, okay, the only straight sections, like they said, are these two straight sections which are x and x, right? So when x is equal to 0, that's when there won't be any sort of a straight section. Again, uh, that's that makes sense, right? So x would be 0 first of all in part 2. Now, if x is equal to 0 and uh, you have your formula for a, right? So you can just find out the derivative of a, which is dA by dr, and you can check whether it has a stationary value or not. Then you just do the second derivative of that, and then so dA by dr would be equal to um, 400 minus 2 pi. Wait, hold on. 400 minus 2 pi r. It is r, right? Yes. Yeah. To be honest, it's pretty simple. So, okay, I'll just go through this quickly. You have your dA by dr, right? R is a variable. You know that x is going to be 0, obviously, in this case. Um, so what you can do is use your formula for the perimeter. X is x would be 0 in that case. So R would be 200 by pi. Okay. Now input that R value into dA by dr, and then that gives you dA by dr. Then you can find out the second derivative, which would just be wait, let me just write that, d2a by dr2 would be minus 2 pi, right, which is less than 0. And like I said, if it's less than 0, um, it's a maxima. Yes, I'm slow. Um, okay. Now we come to TIG and then sequences and series. Finally, uh, do you guys want me to talk? Like, do you guys think I should go through the methods for solving TIG equations? There is the um, ASTC method, which I don't really like. But then there's also the graph method. Like, I wanted to go through the graph method. Okay. I think I'll go through graphs, because a lot of people struggle in graphs. You should do some hard questions and just move on. I would, but then I think it's best if I talk a bit about graphs and then take functions overall, right? Yes. So this is your first transformation question. Um, the curve y is equal to sine x is transformed to the curve y is equal to 4 sine 1 by 2x minus 30. Um, Describe fully a sequence of transformations, making clear the order in which it has been applied. Okay, so my advice would be that please try to visualize the graphs if you can. Okay, so if you have your sine, wait, no. If you have your 4 sine 1 by 2x, the vertical stretch doesn't really matter. You can do that at the end. So think about how the uh, sin x graph would be transformed to sine 1 by 2x minus 30. So you can start by thinking about it as basically, since it's x by 2, obviously this stretch factor would be 2 in the x direction, right? So let's say that you have your sin x, and then it goes to, wait, you know what, I think you guys should get a better idea. You guys would get a better idea if I go through the actual graph. Like, just so that you guys can actually kind of imagine or visualize how that would work. Okay, so this is your sin x graph. Okay, this sequence doesn't really matter, if I'm being honest. Like, sure, there is this certain sequence, but usually the mark scheme accepts various. Okay, I'll just stick to radians. This is a sin x graph. Okay, when you do sine x by 2, that's a sort of a stretch, right, in the x direction, and that would basically stretch your sin x graph in the x direction by 2. So that's the first thing that um, happens. Now after that, so ignore the sin x graph. This is your sin x by 2. Now your stationary point is, for example, at pi. Okay. Oh wait, it's in. Hold on, let me see the question. It's in degrees, right? So I'll just change the scale to degrees. Um, X is greater than minus 360, less than 540. Okay, good enough. Okay, this is a sine x by 2 graph. your for your sin x, the maxima would be at x is equal to 180. Now, when you do minus 30, just observe what happens to the graph. Okay, so for some reason, it's actually getting added by 60, right? It's not getting added by 30 when you do that. So that's sort of strange. It's sort of difficult to um, visualize, but I would say that start by writing this as, so take 1 over 2, factorize that, and you would rewrite this as minus 60 like this. Okay, I'll go through both the methods for this. No, it's not a shift 30 degrees forward. That's the thing. It would be a shift 60 degrees forward. So um, wait, hold on. Right, you have your graph in this form. Okay, so that's the thing. When you factorize out 1 by 2, think about it as sine x 1 by 2 x minus b. Initially, when b is 0, like when it's just sine 1 by 2 x, right? In that case, you're just stretching it by scale factor of 2. Now, when you cause it to shift horizontally, let's say in this case you're shifting it by 60, right? So you would okay, wait. So f of x is sine 1 by 2x. Now, when you're causing it to shift by 60 degrees to the right, you're basically doing f of x minus 60, right? That's basically your new transformation. That's why this would be sine, you can think of it as sine 1 by 2 x minus 60. So, in other words, what you're basically doing is, um, there are actually two ways to go about with it, but the way I was talking about is that first of all, you stretch in the x direction by scale factor 2. Okay, 2. This is your first step. Now, I just talked about basically if f of x is defined as sine 1 by 2x, or like sine x by 2. Okay, if you have some sort of a translation, right? If you're doing 0 minus 60, because look, in this case, when you factorize out 1 by 2, right, you'd end up getting this. So another way to think about it is you have f of x as sine x by 2, and when you cause a shift by this, no wait, that's wrong. That's in the y direction. Go. When you cause a shift by 60 units, okay, so you're shifting it by 60 units to the right. So whatever your x values are, they're getting shifted by 60 units to the right. So your new x values are basically x minus 60. So you do f of x minus 60, and that's how you end up getting this. So you shift it to the right by 60 degrees, and the scale factor, like the stretches by scale factor 2. So you do this, and after that you would do translate. My laptop is fighting me again. This is really annoying. Okay, translate by 60 0 units. My handwriting is really bad, excuse me. Why did you take 1 over 2 out? You don't really have to. This is one of the ways, but we could also stretch first and then translate 2, right? Yeah, so you can also stretch it. Wait, in this case, we are stretching it first by scale factor 2, and then we're translating it. You could also translate it first and stretch it. Both ways would work, okay? If you're talking about in terms of x, like transformations in the x direction, you can stretch first and then you can translate it. or you can translate it and then you can stretch it. But here's the thing, this is one of the ways. If you're doing it the other way, if you're like translating it first, okay, in that case, you would translate it by 30 degrees, not 60. Let me just give you, let me just explain why. So if you have sine of x minus 30, right? So this is a translation by 30 units first. So you're shifting it by 30 first. Then you're going to stretch it. So when you stretch x minus, you're basically stretching x minus 30 by a scale factor of 2. So what happens is that this would become x over 2, but then this part over here would also, in a way, like in this case, you have to visualize it. So you're basically multiplying all the x values by 2, or you're stretching it by 2, and you're also stretching this minus 30 by 2. So minus 60. So if you translate it first, you do 30. Yes, exactly. You do x minus 30 first, and then you would stretch it by a you stretch it horizontally by a scale factor of 2. Both methods work. Now after that, there's this vertical stretch. Doesn't matter. You just stretch it vertically in the y direction by a scale factor of 4. That's one transformation question, 5 marker. I hope my explanation sort of made sense. If it doesn't make sense, just my best advice would be, please open up Desmos or GeoGebra. Just, you still have time, so just see what happens to what happens if you do transformations. How do you know which values to use for solving trig equations, like with the quadrants and stuff? Okay, so here's the thing. I never use quadrants. Like I never use ASTC, which is surprising. I use the graph method. I am going to talk about the graph method when I go through this. If you use the ASTC method, if you want to stick to that, please don't listen to my explanation, because that might just um, confuse you guys. But anyway, yeah, ASTC is easy. It's honestly your choice. The thing is, there's a lot of resources for ASTC, so I don't really need to explain it. It's just all, wait, all students just Cambridge. Wait, no, that's so wrong. A is in the first quadrant, my bad. All students just Cambridge. We don't. Um, why is there music in this channel? Hold on. What about the 4 in sine? Wait, isn't that a stretch yes, that is a stretch parallel to the y-axis. I just didn't mention it because there's not enough space. But yeah, it's just a stretch in the y-axis, uh, parallel to the y-axis. Anyway, moving on, because I really want to sort of go through the graph method. If you're still stuck in ASTC, um, I would say uh, learn the graph method. If you understand it right now, good for you. Otherwise, just watch a video on it. Yes, thank you. Someone finally likes it. So, okay. Of course, my laptop freezes right now. Just give me a minute. My laptop is fighting with me again. Okay, so you have sine 1 by 2x minus 30 is about, you do 2 to 2 upon 4, so that's root 2 over 2, right? So when you encounter a situation like this, where, so I just call this part over here the argument, okay? So whenever your argument is something apart from x, like when your argument is not x itself, but it's like a linear function, you can think about this as a linear function, right? So what I do is I substitute this with a new variable. so that it sort of simplifies my work. I'll try explaining how that works, but just go along with what I'm doing. If it makes sense, good for you. So I start by doing let um, z equal to 1 over 2 x minus 30. So you get sine z is root 2 by 2. So in my method over here, basically you can think of z as your new x value, like new x variable. So again, this might kind of um, baffle you a bit, but let's say, like, look, generally your x and y like your axes are in terms of x and y, right? But what you can do is, for your x-axis, you could define it in terms of z. So you can make a completely new axis. Just bear with me if you don't understand that. It's fine. It's not really fine, but then just check whether you can understand this. So this would be your y-axis, and this would be sort of like your z-axis. So if you were to plot sine z over here, it would be your original. Oh god, it would be your original sine z, um, sine z graph. Okay, just fit that into your mind if you really want to do the um, graph method. Okay, now here's the thing. This domain over here is in terms of x, but you'd have to find out the new domain which is in terms of z. So you'd start that by by multiplying with 1 by 2. So 0 less than equal to x over 2 less than equal to uh, 180, and then you do minus 30, so that you get the new domain for z. So minus 30 less than equal to z, or I'll just write it as x over 2 minus 30 less than equal to 180 minus 30, so 150. Now here's the thing. Uh, this is basically your domain for sine z. Okay, so yeah, just try remembering that if you can. Then your new domain. The best thing for in graphs is that you can sort of highlight the acceptable domain. So minus 30 would be somewhere along here. Okay, my 150. So over here, this is 90. The maxima is 90. The x-intercept would be 180. So 150 would be somewhere about here. Okay, not exactly. Then you can just make the line y um, is equal to root 2 by 2. Yeah, this is a pretty, it's not lengthy, but then personally I think this gives you all of the values. So root 2 by 2 would be somewhere over here. Anyway, um, now you just find out the intersection between sine z and root 2 by 2, right? So, first of all, find the reference angle. So, sine inverse of root 2 by 2. So first of all, I'm getting z as 45 degrees. Okay. Now if I were to find out the next uh, value, so there's also some um, other essential logic for graphs. So you can use a lot of symmetry for graphs as well actually. So let's say you have a point over here, okay? Now I'll just label this as 45. Let's say the x coordinate of that is 45 degrees. So 45. Alright. Now let's say you want to find out the next value where the y value is the same. Because look, sin x basically represents your y value. And whenever you have equations like sin x is equal to root 2 by 2, you're basically saying the y value is root 2 by 2. So you can make a horizontal line over here. So to find out the next intersection, since it's since it's symmetrical about 90 degrees, you can actually do 180 minus 45 degrees to find out the next value. So 180 minus 45, that would be 135 degrees, which is again acceptable. Um, okay, laptop. Wait, just give me a minute. Yes, okay, we're back. Right. So I got 135 by doing 180 minus 45 degrees. Now, these aren't your final answers. So you would um, use the substitution over here. No, wait. You would use the substitution you did above. Okay. So, um, wait. S z is equal to 1 by 2 x plus 30. Wait, sorry, it's minus 30. Then z plus 30 is equal to 1 by 2 x. X would be equal to 2 times z plus 30. So z plus 30. Now just use that, just use these two values for z, input that into your substitution, and then you would get your final value, which would be in for x. So I'm getting 150, comma, and then 2 times 135 plus 30. So 330 degrees. I also have the mark scheme for this. Um, you guys can go through that just to see whether I'm right or wrong. I'll open the mark scheme for this just to show that it's um right. Hold on. Oh wait. Um, pure one questions. In fact, I'll upload the mark scheme for these questions as well. That would be somewhat helpful. Um, is the transformation in sequence? Yeah, I just covered a transformation question like a while back. I talked about like um, the multiple ways you can do that. It's in fact it's part A over here, right? So I'll have to find it. Just give me like a minute. Um. Okay. So you got. So the values I got were 150 and 330, which are correct. You can use ASTC as well. I have no issue with that. This is like my preference. Okay. Now you have the graph for a cos bx plus c. Find the values of the positive integers a, b, and c. So you can start by using any maxima or minima that you know. So for example, at x is equal to 0, it would be cos 0, which is just 1. So the y value is 8. So your first equation is 8 is equal to a plus c. Um, After that, um, wait, hold on. Let me see. Um, the, when this entire thing over here would be 0, right? So when this entire thing is 0, that's what your minimum value would be, right? Because that's how the cost function works. Basically, when your a is probably, yeah, a is something positive because it's your usual cos x graph. It hasn't been reflected or anything. So when this entire thing is 0, yeah, it's your amplitude. You can use that logic as well. So c would be equal to -2. And then you get 8 is equal to a minus 2. A would be equal to 10. Hold on. Think I may have messed up too. Uh, Basically, at x is equal to 0, it would simply be at x is equal to 0, y is 8, right? So you can make the equation y is equal to a cos 0 plus c. And cos 0 is basically 1, right? If you look at the original cos x graph. I think I may have done something wrong too. I think it should be half of 10. I don't know why I'm getting 10. So, wait, just give me a minute. Is 8. I'll just use a amplitude logic. Basically, amplitude would be the half of um, this thing over here, right? And this is 10 units um, long. So half of that would just be 5. So your amplitude is just 5 in this case. I think I messed up in some other logic. Oh, C is. Wait. Oh, yeah, right. My bad. Because the least value that cost graph can. Oh, I'm tweaking right now. I'm so tired. Anyway, C is minus C. Apologies. A would be 5. Okay. And then you have your B, which is period. Now, you have two oscillations in 2 pi. The original cos x graph has one oscillation in 2 pi. So you basically contracted it by, or like this um, stretches by a scale factor of 1 by 2. So B would just be 2. I'm sorry, I'm sort of a bit tired. Okay. Now, for this, you're told that your function a cos bx plus c is equal to 6x by pi, right? So for these type of questions, since you're finding out the intersection, you what I usually do is I make a rough sketch of the line, like the rough sketch of 6x over pi, for example. Oh wait, um, what do I keep on doing wrong? Wait, hold on. When b okay, 2 pi is over here. So 8 is equal to, oh, I'm so sorry. 8. Yeah, 8 is equal to 5 cos 2 pi plus c. So 8 is 5 plus c. We're gonna plug in pi into the x. Um, no. Look, wait, wait, hold on. Let me see your method. We're gonna plug pi into the x. Um, so I suppose you can do that to find out when a cos bx plus c is equal to 6. That logic would work as well, I guess. But what I usually do is just find out the y and x intercept of your line. Okay, so wait, hold on. Let me just erase this. Um, okay, so this is just a linear. You can think of this as a linear function, right? 6x over pi. So when x is 0, y is 0. So there is no intercept. And then you can take some random values. Okay, yeah. So we're going to take pi in this case. And y would be equal to 6. So this is your point. And then that would give you the intersection. So 1, 2, and then 3. So there are 3 intersections. Now again, for this, you can think of it as a linear function. Um, the slope is negative, and the y-intercept is 6. Okay. So wait, let me just erase this line over here. So this is your y-intercept. When x is equal to pi, that's when you get 6 minus 6, right? So when x is pi, the equation y is equal to 6 minus, hold on, 6x over pi. Because you're basically finding out the intersection between your trig graph and your uh, function 6 minus 6x over pi. So when x is pi, it would be like this. Okay, oh god. Okay, but it's accurate. So you would have 1 and then 2 intersections. Okay, moving on. Now, in this case, you have a sine square x graph. Okay, so just keep that in mind because when you have your, let me just show it to you guys. When you have your original sine x graph, right, the range is from -1 to 1. But when you take the square, uh, you can think of it as uh, taking the absolute value. So when you're doing sine square, it's like taking the positive value for everything. So if you were to do sine absolute value of sine x, it's kind of like the y value can never be negative no matter what. What was the answer for the previous b I I? Wait, b I was 2. So okay, I switched languages. Anyway, right. So sine square x would actually be sort of like absolute value of um, sin x. Just you don't really need to know about this in depth. I'm just trying to show you the graph so that you have a better sense. But basically, y can never be negative, and then your least value would be 0, and your maximum would be 1. Because the thing is, it's just sine square x, right? You're you're basically squaring sine x. The maximum value for sine x is 1. So even in sine square x, the maximum value would be 1. Are we supposed to square all x coordinates? No. You're not squaring the x coordinates, you're squaring um, sine x. So in other words, you can think about it as y is equal to sine x. And then you're kind of doing y square, okay, to get the new function. So you're just doing sine square x, not x square. Anyway, let me go through the question now. So p sine square 2x plus q is defined for from 0 to pi, okay, where um, p and q are positive constants. The diagram shows the graph of y is equal to f of x. We don't really have a lot of questions left, so I think I'll be done with this. And then, if you guys have any doubts in any specific FebMarch papers, I guess you can ask me. I don't think we have enough time to like go through the entire paper because the session was really long. So yeah. Anyway, right. So the diagram shows f of x. In terms of p and q, state the range of f. Okay. So for that you can you have your sign. Wait, let me just write it over here. Can you do question 5 for 24 winter 13? Wait, can you send me the question? Like, can you send the image or something if possible? P sine square. Like the order. Um, okay, just let me just do this question, and then if you guys have any doubts, just ask me. I'll be there. So, anyway, this is your sin x graph, right? So your minimum point would be when x is equal to 0, for example. So, like over here, since wait, hold on, but then p is negative, is it? Oh no, sorry, my bad. This is your sine square x, right? So your minimum would be when x is equal to 0. So that is just q. I think that makes sense. Okay. When this entire thing is basically 0, that's when you get the minimum. Because the thing is, it's sine square x, right? Sine square 2x. So there is no value where sine square 2x can be negative. So this entire thing in the box can never be negative. So the minimum would be when it's q. And yeah, the maximum would be when it's p plus q, because sine square x um, can only be equal to 1 at max. Yeah, I shared a link for the drive. I'm tired of sharing it. I'm kind of tired. Anyway, so f of x is greater than q, greater than equal to q, my bad, and then less than equal to p plus q. I didn't get the concept of this. Okay, yeah, I'll go through this. That's not an issue. If you want, I can tell you how you'd work with it verbally. Okay. Um, if you still don't get it, I'll show you the working. So, um, wait, let me just. Since I'm recording, let me just show the question. Why is q the minimum? Because it's sine square 2x, right? So sine square 2x can never be negative, first of all, and then that means when the entire term sine square 2x is 0. Um, okay, wait. Like I said, um, over here. So this is your sine square 2x, okay? The minimum value you can take is 0. The maximum value you can take is 1. So your maximum value would be when sine square 2x is 1, which means it would be p plus q. And your minimum value would be when sine square 2x is 0. That's when it would be q. Um, okay, let me just finish this real quick. Now state the number of solutions of the following equations. So when y is p plus q, that's just the maximas, right? So just make a line over here. You have two intersections. So that's over here. That's the answer. Next, you have when y is equal to q. That would be over here, which is 3. Can you explain the range thing? Okay, third time. But anyway, basically f of x is p sine square 2x plus q, right? So this entire thing, notice that since it's sine square 2x, right? Sine square can never be negative. It's always going to give you a positive value. So the minimum value for f of x, like for this graph, would also be positive. Um, because like as you can see, the thing that I marked in the box, this thing can never be negative because first of all, sine square can never be negative, and they clearly told you that p and q are positive. Okay, so when this entire thing is 0, that's where when p sine square 2x is 0, that's where you get the minimum value for f of x, which is q. And the maximum value would be when p sine square 2x is equal to p, because sine square 2x can have a maximum value of 1. Okay, I'm tired, so I'm gonna move on. Anyway, now you have f of x is p by 2 plus q. So 0.5 p plus q. Now I think you can do it several ways, but obviously 0.5 p plus q would be between q and then p plus q, right? It obviously has to be between it because you're just multiplying p by 0.5. So you can just make some random line over here, and clearly there are going to be four intersections no matter where you look at. Yes, I have the mark scheme. It's in the drive as well. So you can check that too. Um, then you have this. I'm not gonna really do this. I'm tired. It's pretty easy again. So yeah, that's pretty much it. Um, oh, like, do you want the solved question paper like this one, or do you want the question paper? Yeah, all right. Okay, I'll upload it in a while to the drive. Till then, just use this drive link, okay? Okay, I'll send the solved one. No worries. Okay, now doubts. Do you have any target questions? What do you mean by target? Yo, can you please explain transformations? Um, Here's the thing. I went through a really um. Wait, hold on. I went through this um question which covers transformations. I'm sorry, my throat hurts a lot. Let me just drink water. Okay. I did not cover Feb March. I did not get time, but I did solve it. So if you guys want the solved version, or if you guys want the MS, um, just check the drive. I'll upload the solved versions of this and Feb March. I'll just do it later because I'm just tired. Okay. I'll go through transformations. If you guys have any other doubts, keep them ready. Um, where are transformations? So it was right here. Yeah, there you go. Okay, so this was the question that I covered for transformations. This has a horizontal stretch and a horizontal translation. Okay. Uh, I look, differentiation and then integration is pretty simple if you like know what the rules are. Um, I would say just go through say my exams now because it's kind of late if you want to learn that now. Anyway, let me go through this again. So you have 4 sine 1 by 2 x minus 13, right? So just for um, just for things to be much simpler, you can start by factorizing 1 by 2. So when you factorize um, 1 by 2 from x minus 30, you end up with this function over here, 1 by 2 x minus 60. Okay. Now, here's the thing. Um, I don't have time for that right now, so I would just say check Matli by Sar and whatever. I'm not planning to like go through those essential concepts. Anyway, so now you know that it's basically sine 1 by 2 x minus 60, right? So you can think of it as first of all, you had your function f of x, which was sine 1 by 2x, right? That's like with the stretch across the x-axis by a scale factor of 2. Now, let's say that you do translation by 60 units to the right. Okay, so it's basically kind of like doing f of x minus 60. Like whatever your x values are, they're going to get translated by 60 units to the right. That's how you would end up getting sine 1 by 2 x minus 60. So basically, you would do a stretch. Wait, I think I wrote that. A stretch in the x direction by scale factor 2. and then you translate it by 60 units to the right. The other method is that you would translate it first and then you do the stretch. But look, your main goal is that whatever transformations you do, you have to get sine 1 by 2 x minus 60. So if you don't want to do this method, like this first method of stretching, you first of all you'd basically translate it by so you'd have f of x is sine x, then you'd translate it by sine x minus 30. Okay, and here's the thing: when you're basically stretching across the x-axis by a scale factor of 2, you can think of it as x minus 30 basically getting stretched by a scale factor of 2, right? But again, in for transformations when you're dealing with x, you do the reciprocal. So that's why it would be sine x by 2 minus 30. You're basically just stretching it by 30 units. I'm kind of tired right now. I'm sorry. Okay, apart from that, are there any other doubts? I think I went through most of the stuff. So, okay, yeah. If there are any other doubts, just clear them because otherwise I'll just wrap up. Buddy, I I I can't go through a new topic right now. I'm kind of tired. Thank you. Yeah, if you guys want to leave, just that's fine. What is geometry? Great question. Yeah, I did study for it. That's why I'm hosting the session. Good luck. Good luck, whoever. Um, I'll just ping you. Good luck. Um, Look, I'll be uploading the recording right now. Okay. So just go through the recording. If you don't understand anything, um, just reach out to me. No problem, ins. Um, I'm doing AS with you guys this year. Haha. IGCSE, I gave AD math. I got an A star. Anyway, good luck, guys. Any doubts? Um, a lot of people were asking doubts before. Um, Wait, how do I do this? The curve with equation x squared plus 2x minus 5 is transformed to a curve with equation 4x squared plus 4x minus 5. Okay, so just focus on the 2x term in the original equation. It's clearly f of 2x, right? You're inputting f of 2x, and then, for example, you do 2x the whole square, that would give you 4x squared, and then if you do 2 times 2x, that would give you 4x. So you're just doing f of 2x, which means you're stretching along the x-axis by a scale factor of 1 by 2. Yeah, good luck, Mystery. Bye, T. I think you're leaving. Oh. Alright. If you guys have any doubts, you can stay. Otherwise, yeah, that's pretty much it. Thank you. Okay, I think I'll wrap up now. Yeah, there's only a stretch in the x-axis, by the way. There is no other sort of, because they specify that there's a single transformation, right? So yeah. Oh, why? Just go study. Um, yeah. So smart. Anyway, is there no more over here? How does the session end?